Okay, part 2 of the story problems. There's 2 types of problems here. One person buys 5 pounds of oranges and 8 pounds of apples for $11.47. Another person buys 3 pounds of oranges and 2 pounds of apples for $4.25. Find the cost of a single pound of oranges and a single pound of apples. So we're looking at the cost of apples for a pound and the cost of oranges for a pound. So if I get decimals, that's okay. Now, again, the little XY relationship needs to be thrown out the door with the line and the table and all that, because you have money spent on 2 different things, apples and oranges. So you're going to make a table. Now, somebody might be thinking, will we make 2 of them because there's 2 people? No. Okay? You don't have to do that. Step up to your grid. And you have together, and then you have the apples and the oranges, or oranges and apples if you just want to put them in the order that they're listed in the problem. Okay, then we go down. How many units per unit? And total. Now you do this just like I told you the other day, filling this out. Well, the first number I see a bunch of numbers that are not cost related. You got 5 pounds of oranges, 8 pounds of apples, 2 pounds of apples, and 3 pounds of oranges. Okay? So what I do is I put 5 pounds of oranges, 8 pounds of apples right here. Give yourself some room here, because later on you have 3 pounds of oranges and 2 pounds of apples. So 3, 2. You want to put those in the order that you have them in the problem. 5, 8, 3, 2. And then together that guy would have 13 pounds of the 2 fruits combined. That guy would have 5 pounds of the 2 fruits combined. Okay, now I go down here and find my totals. Well, there's 2 total costs, okay? You have the $11.47 first for the 5 and the 8, then you have the $4.25. So since we know this and this won't be needed. Okay, well that's pretty much it, okay? So then what we're going to do, these are the 2 things I need to figure out. We're going to let this be represented with an x variable and this represented by a y variable. Now I'm going to put 2 x's, okay, because the cost per unit's not going to change for the oranges. So the guy who's buying 5 pounds of oranges pays x dollars per unit, the same with the guy that buys $3, and then the same with the apples. So what I do is I take 5 times x, that would be 5x. And then I take 3 times x, that would be 3x. So we're going to have 5x and 3x. And 8 times y would be 8y, and 2 times y would be 2y. So then we see our 2 equations right there together. So these are my equations, and I just stack them and employ the elimination method. So we have 5x plus 8y equals 11.47. We also have 3x plus 2y equals $4.25. Now we'll multiply the top equation by 3 and the bottom by 5, so that then the x's will have the same coefficient of 15, because you can have 15x plus 24y. And then I take 3, turn my calculator on, times 11.47, you get 34.41. Be watching out for the decimal places. The bottom, you're going to get 15x plus 10y equals $21.25. Okay, then what I can do is first off change that to the opposite, and that's going to take you to 0x, negative 10y, and 21.25. So then that's going to be 14y, and that gets rid of the x. Then we take 34.41 plus negative 21.25, and that's 13.16. Now you got multiplication by 14, so you divide by 14. And 13 point, you might think this is going to be weird, but it's really not, because 0.94. Okay, so the y's, both of them, are 94 cents. You need to put 0.94 for your answer, and that's your apples. Now, unfortunately, we can't just subtract, okay? So you have to go the old way and take one of the two original equations, 5x plus 8y equals 11.47, and then replace your y with 0.94. And you got to take 8 times 0.94. 7.52. So 5x plus 7.52 equals 11.47. Okay, then I'm going to minus the 752 and divide by 5. Okay, that's going to be $3.95. And then I divide by my 5. I get 79 cents. Okay. So 94 cents and 79 cents. Okay, let's do another one. This one is going to go a little bit quicker. Angie and Kenny play online video games. Angie buys one software package and 3 months of gameplay. She pays a total of $65. Kenny buys one software package and 2 months of gameplay. He pays a total of $50. Find the cost of a single software package and the cost of a single month of gameplay. So how much a software package costs based off the information, and how much a month of gameplay costs. Okay. Now again, you got money, and it's two different things: the software packages and the months of gameplay. So again, we're going to design the grid. Okay. You're not going to go with the XY table, okay, because it doesn't make any sense. I mean, Y would be dollars and X would be what you're buying, but I'm buying two different things, so that's not going to make any sense. So you have together, and then the two things you're buying are the software packages. I'll just put SP, and the months of gameplay, I'm just going to put MGP for that. Okay, then how many units per unit and total. And then, of course, money is your dependent variable unit, so money total, money per unit. Okay, go up here first. So non-money numbers. You got one software package, 3 months of gameplay, and then later on we have one software package and 2 months of gameplay. So I put the 1 across from the 3, 1, 3, and together that would be 4. Then 1 and 2, and together that would be 3. Now, there's got to be two totals in, and there must be. So equals equals, you're going to have $65 and $50. You need to put them in the order, in chronological order from the problem for this to work out. So that's not needed. Okay, so that's pretty much all the information I have. Now I find what these things cost. Okay, so X and Y. So you're going to have 1X and 1X, and then 3Y and 2Y. Now, I don't think we're going to have to multiply here once we stack these together. Because if I just make that of negative x, negative, negative, then the x's zero out. Okay, they eliminate. This is called the elimination method. The one where you box up the letter when it's by itself, that's the substitution method. I don't really use that on story problems a lot. 1y, you could technically, but it'd be kind of a waste. Okay, I don't need to divide by 1, that's a waste of time, so y equals 15. So the months of gameplay are going to cost you $15, okay? Now, how much a software package cost? Well, so we know that 1x plus 3y equals 65, okay? And we plug that, substitute the 15 in for the y. Then 3 and 15 gives me a product of 45. Then you minus 45 and you get 20. And really dividing is kind of a waste of time. So that's going to cost $20 for the software package. Okay, next problem. Two schools buy helmets and uniforms from a store. The school buys 5 helmets and 7 uniforms for $250. The other school buys 7 helmets and 10 uniforms for $354. Find the cost of a single helmet and the cost of a single uniform. So we have together, the two things we're buying are the helmets and the uniforms. Okay, so how many units per unit and total? Okay, so money total, money per unit. Okay, so look for your non-cost amounts. Well, 5 helmets, 7 uniforms, 7 helmets, 10 uniforms. So the 5 and the 7 make 12 together. And the 7 and the 10 make 17 together. So there's no equations on the top row. Okay, now there's got to be 2 total costs, and there is. There's $250 and $354. Not going to need that. Okay, so the helmets, let that be represented with X. Let the uniforms be represented with Y. So 5 times X, 5X. 7 times X, 7X. 7 times Y, 7Y, 10 times Y, 10Y. Okay, so we have 5X plus 7Y equals 250. Then we have 7X plus 10Y equals 354. Okay, then you apply the elimination method. So you're going to times by 7 on the top, times by 5 on the bottom. So you're going to have 35x plus 49y, then 250 times 7, I think that's 1,750, I'll double check, yeah. At bottom you're going to have 35x plus 50y, 1,770. We add these together, but you got to negative that one so that that zeroes out. And then 50 is negative, 1,770 is negative. So I'm adding 49 to negative 50, it's negative 1y. 1,750 plus negative 1,770 is negative 20. And you divide each side by negative 1, and you get 20. Okay. All right, so the uniforms cost $20. Now to find the cost of a helmet, just use because you can't just subtract here today, okay? So 5x plus 7y equals 250, okay? So y would be 20. 7 times 20 gives me a product of 140. So then we have 5x plus 140 equals 250. Subtract 140 from each side and you get 110. So 5 times x equals 110. Then I divide by 5 and you get 22. Okay, by now you should see how that works. I'm going to cross out this problem here. I don't have to do it now. Here's the other type of problem. It says a writing workshop enrolls novelists and poets in a ratio of 5 to 3. Okay? There are 24 people at the workshop. How many novelists, how many poets are there? Now, this is a rate. You're finding the number of novelists, the number of poets. Okay? Now, here's what a ratio means. It says novelist first, poet second, 5 first, 3 second. Okay? Now, there's 2 ways you can do the problem. Okay? I'm going to do it 2 different ways. Pick the one you like better. This one I'm going to do down here is quicker. Okay? Okay, so not in that order, 5, 3. So 5, 3. There's actually 24 people at the workshop, so that would be 8 people. Okay, 5 and 3 makes 8. Another 5, another 3. So 5 and 5 is 10, 13, 16. Okay, you're just adding them up. That's good. You got to get it to 24 people. Okay. 5, 3. 5, 5, and 5 is 15. 3, 3, and 3 is 9. 15 and 9 makes 24. Okay, so there's 15 novelists and 9 poets. Now, that's the long way. Here's the short way. You're going to make a box like your fraction box that you had earlier this quarter. Okay. Instead of a fraction, though, it's ratio and actual. Instead of fraction and actual, it'll be ratio and actual. Then you're going to write novelists and poets, okay? Novelists, poets. You're not going to put the not poets, okay? That's not how a ratio works, okay? It's similar. It's very similar, this process, to the fraction, but they are not exactly the same. They're different in how you label the sides, and they're different in where you place the ratio. Novelists and poets is 5 to 3. So we go 5 novelists, 3 poets, then we add these together, and that makes 8. Okay. Now before, if you remember the fraction, if you recall when we were doing the fraction problems, we would put the top number, the fraction, in here, and then we put the bottom number here. So no. Okay. If you made this a fraction problem, then the novelists would be 5/8, the poets would be 3/8, but we're not going to worry about that. Okay, 24 people at the workshop. Well, that's your actual total. Okay, then you're just figuring out 8 times what's 23. Well, 24 divided by 8 is 3. So we multiply 8 by 3, 3 by 3. That's your multiplier. So you divide 24 by 8 to find your multiplier to get from the ratio to the actual. So 3 times 3 makes 9. 5 times 3 makes 15. So novelists, 15, and the poets is going to be 9. Okay, at a certain high school, 350, I'm going to use this way. You could also do that way, but that way does take longer. It's not on, that one didn't take long, but there's somewhere it would take forever, okay? At a certain high school, 350 students are taking an algebra course. The ratio of boys to girls taking algebra is 33 to 37. How many girls and how many boys are taking algebra? So girls, or excuse me, ratio actual. So now it says boys to girls, so you got to put boys first, girls next, because that's the order the ratio is presented to us. Then total. So boys to girls, that's 33 to 37. Okay, if I had 33 and 37, that takes me to 70. And then that 350 students taking algebra, that's your actual total. So we want to know the boys and the girls. So I have to find my multiplier. Well, if I take 350 divided by 70, that equals 5. So 33 times 5 is 165. 37 times 5 is going to be 195 or 185. That was off. Good thing I did it on my calculator. So boys is 165 and the girls is 185. Okay, a pet shelter has cats and dogs in a ratio of 5 to 1. There are 120 animals at the shelter. How many cats, how many dogs are there? Okay. Now this one would take forever if you listed 5, 1, 5, 1 until you had a total of 120. So that's why you should be using this thing I'm showing you here. So ratio and actual. Instead of fraction actual, it's ratio and actual. So that means when we label it, we want the ratio of the two things, 5 to 1. That's cats to dogs. And then total. Okay. 5, 1, and 6. You just add these two. That's how you get that one. 120 animals at the shelter, so 120. So 6 times what's 120? I mean, I don't know. So divide 120 by 6, it's 20. I guess I do know, I'm just telling you. So 5 times 20 is 100. 1 times 20 is 20. So we have 100 cats and we have 20 dogs.